Hi, everybody. It's Bruce Collins here at Cambium Networks. Thanks for joining today's webinar session. We're going to be providing some updates on the cnReach product, some new hardware and software features that are in the pipeline here and imminent here between now and the beginning of fourth quarter. So there's a number of new capabilities that we'll discuss. I will do a brief background for those of you that aren't familiar with cnReach. I'll do a little bit of a background on what cnReach is about, and then we'll focus a little bit on what's coming next. And this will be a fairly brief webinar, but I do encourage you to ask any questions as there'll be plenty of time for Q&A and discussion if you have any topics you'd like to cover. So with that, I will get started. This is being recorded and will be available. You'll get a copy of the link via email where this is located on the forum, on the Cambium Networks community. And again, encourage you to ask any questions as we go. So just as a high-level starting point, where does cnReach fit into the overall Cambium Networks portfolio? When we look at what product sleeves within the entire Cambium product lines fit into industrial applications, these are the ones that we kind of highlight and typically are using in industrial deployments, whether it's oil and gas, electric utilities, mining, some smart traffic and traffic control scenarios, as well as significantly water and wastewater treatment, where we do a number of deployments around the world. So we're starting with licensed microwave. We can do gigabits per second, so lots of capacity. The sub-6 gigahertz backhaul, which is our PTP, 450i and 670 product lines, very good for delivering a few hundred megabits per second into a particular area. Then we have, of course, our point-to-multipoint 450i platform, and for those with larger scale requirements, can go to a 450m. That's very well suited for aggregating lots of different data points, access to the network, and then video surveillance applications, so remote access deployments. We have our cnPilot outdoor portfolio, which is very well suited for industrial applications. And then what we'll focus on today is cnReach, which is really focused on control and SCADA monitoring of infrastructure. So you can use cnReach to monitor pumps and substations and any kind of device that you want to both monitor and control remotely using typical SCADA type protocols like Modbus or DNP3 and those types of capabilities. One of the big drivers for a product like cnReach is migrating from legacy wireless SCADA systems to more modern systems. So I like to show this as an example of a before and after scenario. This is an example of a legacy SCADA system, and these are deployed literally tens of thousands of locations around the world, perhaps even hundreds of thousands. And what you'll see that makes them legacy here is it's serial-only communications. 9600 baud is typically the max. There's no way to remotely update firmware. You'll notice that they're using handwritten EPROMs in this case. There's no remote management to know what's happening with that remote area or that device that's being monitored or managed. And then oftentimes these are hardware and software solutions that are no longer supported, so they're just not available to update or buy spare parts for or basically maintain. So it becomes a critical support and maintenance effort to migrate from these legacy systems over to a modern system. So this is the before picture. I go to the next slide. This is the after picture. So this is that same cabinet that now has been updated to a modern environment. And you'll notice they could have gone to a much smaller cabinet, but in many cases, they just replaced that panel that goes into the back of the cabinet. So without having to redo infrastructure for the actual mechanical enclosure and the antenna and the cabling up to the antenna, they can leave that in place and just replace that panel. And the other things you'll notice in here is that it is based on IP communication, so it's all standards-based IP. There's centralized network management, either via the GUI directly on the radio or what I'll show you here in a moment is a sneak peek at our CN Maestro support for cnReach. There's fewer discrete devices. There's a lot more integration that happens with the cnReach radio. So in this case, cnReach has built-in general purpose I/O. So the sensors are connected directly to the cnReach radio and can be read and monitored from the SCADA master back at the headquarters just using Modbus TCP. We also do some integration things like Modbus TCP to RTU conversion, which can also eliminate external boxes. And we'll talk about a wireline replacement feature, which can eliminate RTUs altogether for certain simple automation applications. These are all software-defined radios, so down the road we can push firmware updates to these. We can add new capabilities both in the on the IT side of the radio, so adding new security features, adding new performance features, but then also on the radios themselves, adding new, changing the air interface, modifying, adding modulations, air protocols, all that kind of things that can be modified in the radio itself. And you can see it's a pretty capital efficient way to migrate because it's a private network. It's a reusing a lot of the infrastructure. So it's a pretty simple way to migrate what is a legacy maintenance headache or nightmare over to a more modern manageable system. So you end up with the net result being fewer truck rolls, faster response times, reduced maintenance costs and management costs, and of course, as goes along with all critical infrastructure, is the ability to continually increase security capabilities. The particular example I just showed you, which was the before and after picture, is actually a water distribution and management district in the Western United States. In this case, what they're doing is, I like to use this because it kind of gives a straightforward example of what a typical application might be for a cnReach deployment. This is a water tank monitoring application, and what they're doing is, you see up in the upper left is the AI, and DI stands for analog input and digital input. And in the lower left, there's a picture of a water tank sitting up in a small subdivision of homes in one part of the city. And what they want to monitor is how much water's in that tank. So they use a pressure sensor to figure out what's the water level. They have a float sensor to figure out if the water is starting to overflow. So it's a kind of a fail-safe on the water level. They have a hatch cover, so if that door into the tank gets opened, it flags or triggers a signal back to the central headquarters. That panel itself, if somebody opens the door to the panel, that also triggers. And then you'll see inside there's a red button that if a technician's on site and they need help, they can push that red button and it signals back that there's an issue that needs to be taken care of. This is using 900 megahertz unlicensed for cnReach, the point-to-multipoint scenario. If you look at the right-hand side, there's the cabinet itself, and then up above there is a Yagi antenna pointed back down towards the city. This is about an 8-mile link from here back to the headquarters, about 7 to 8 miles, about 11 kilometers back to the headquarters. And they're pulling it with Modbus TCP software to pull those sensors that, if you look in the picture in the upper middle, you'll see those blue wires coming into the top of the radio. Those are directly wired to those different sensors. So again, a nice tight integration at this particular cabinet. Of course, you could also put an external PLC or RTU and connect that via Ethernet or serial. So you have other options to expand the I/O as needed. Here's another recent example that we're deploying out we're helping with one of our partners deploying this out in Colorado. This is a natural gas pipeline, and what's interesting about this one is it is over a long distance of over about 200 kilometers, 300 nodes, and they're monitoring for flow rates, looking for leaks, detecting leaks, and just monitoring basic temperature and pressure, so the overall health of the pipeline. What they're doing here is they're combining Cambium broadband radios to feed different points along the pipeline, and then using cnReach as sort of that last mile to provide connectivity to each of the individual nodes. And this is a licensed narrowband. So it's licensed 900 megahertz, the MAS band. We also have cnReach available in 450 megahertz and 220 megahertz. So there's a number of different, and 700 megahertz for that matter. So there's a number of different licensed frequencies that can be used where the operator has exclusive access to that band and can get and use that for their critical infrastructure communications. In this case, then they're also using the broadband signal to basically feed that or provide backhaul to the different points along the pipeline. So there are a lot of different potential customers and users for cnReach. If you look across this list, these are some of the examples of different types of companies around the world that are using the products. So of course, oil fields, electric utilities. We talked about a pipeline application. We have some customers in the rail industry and the mining industry using this for digital signage. So very remote areas where they want to push content out to these digital signs. They can use cnReach for that. Flood management, we have a nice project down in Colombia that is using cnReach for managing floods. The number of water, I mentioned before, water utilities is one of the largest sectors or verticals for cnReach. And then, rail and mining I talked about as well. So lots of different opportunities or areas to leverage the capabilities of cnReach. The way the product is deployed, it's typically the same radio can be deployed at any point in the network. It can be typically deployed as either point-to-point or point-to-multi-point. We also support some capabilities for repeater nodes. So if you're trying to repeat a signal into a specific area that is difficult to reach, either because of the length of the distance, or the foliage, or even going up over a mountain down into a valley is another typical application for a repeater. We offer both what's called in the middle there, the back-to-back repeater, and that's using our dual radio module. So in this case, the cnReach module itself has two radios, one in this case pointing in the westbound direction and one pointing in the eastbound direction. And that radio can basically communicate both west and east at the same time. So you don't lose capacity when you go through a repeater node. The store and forward repeater is a more typical or classical approach to repeaters. In that case, the radio is going to talk part of the time in the west, and then it's going to turn around and talk part of the time in the east. So with a store and forward repeater, you automatically lose about half the capacity when you go through a repeater. So you have some options and trade-offs there between going with a store and forward repeater or a back-to-back repeater. So a couple of different ways to go there. From the connectivity side, each cnReach radio has two Ethernet ports, two serial ports, and can have one or two radios, so that single radio or dual radio module. And then also what I showed in the case study before was an optional general purpose IO, which gives you 8 ports of analog or digital connectivity in that green connector you can see on the left of the radio or facing us in the right-hand picture, or the middle picture. That is 8 pins of analog digital IO that you can control input signals or drive output signals. You can do things like count pulses coming in there. So if you're doing like a pulsing or metering application, you can count pulses as well. From a protocol standpoint, you can connect to anything with a serial port, anything that's running a SCADA control system, perhaps using Modbus or DNP3 or any of the other control system protocols, because they pass through the radio transparently as a layer 2 IP device. We can also do things like Modbus RTU to TCP conversion. So if you're wanting to serve this radio with IP, but you're talking to a serial port behind it, you can do that conversion in the radio, so Ethernet to serial conversion. That's a lot of flexibility in how that gets set up between terminal server, terminal client interfaces. So just about any kind of industrial device that you want to connect to, cnReach has the options and capabilities to do that. Just a brief summary on the platform itself. I've covered most of this. You'll notice the number of different bands that are available. We recently introduced a 450 megahertz that we call the ETSI Red radio that's suitable outside of the U.S. And it's really become a popular radio because it does it does 8-watt transmit power, which is very competitive and differentiated in the market. It also covers the entire 406 to 470 band. So it's a lot of frequency flexibility and lots of transmit power with all the other features and capabilities. It's become quite a popular device for those of you that are not in the US or Canada. We do test every single radio over temperature. So each radio is tested up to and functionally performs at 85C. So this is 100% testing to 85C. That's unique in the industry as well. The locations where these radios go can often be very hot areas, both because of the temperature in the environment, but also because of the machinery that they're operating around. So the temperature rating on this is higher than the other products in the Cambium portfolio. Power consumption is important. In many cases, we can reuse existing solar panels so that the device can actually operate off of solar. And then an area that it's unique within cnReach within the industry is some of the scalability features. And this is not new to those of you that are familiar with Cambium products, because all of our products within the portfolio do TDD or time division duplex synchronization and adaptive modulation. And cnReach is no different. So you can do frequency reuse with licensed band channels, and you can do adaptive modulation to get the most efficient use of the spectrum. So much like all the other products in the Cambium portfolio, spectral efficiency is a key attribute of cnReach. Security built in, so 128 or 256 AES encryption is built into the radio. And as I'll show you here in a sneak peek is a preview of the cnMaestro support, as well as it's supported in Link Planner for designing links and understanding what the capacity and availability of a particular link would be. I won't go through all the specs and details. Those are all available on the website in various spec sheets. I do want to point out one thing on the 900 megahertz radio. This radio is also another unique attribute, is that it can support both MAS licensed mode in the 900 megahertz band, as well as ISM unlicensed mode in the same radio. So just via the GUI, you can switch it back and forth between unlicensed operation and licensed operation. And this has become a pretty compelling feature for those customers that are migrating from one direction to the other, or are even looking at, can I run it in unlicensed mode for part of the time and switch it back to licensed? So maybe I run it in unlicensed to push firmware updates because it's got more capacity. And then I swing it back to license mode when I put it back into operation. So some flexibility that you have there with the cnReach radio. Here's the ETSI Red radio I mentioned. Again, up to 8 watts of transmit power and that wide frequency coverage from 406 to 470. And the last thing on the product itself I'll mention is the I/O expander. We're starting to see more deployments of this product. This is effectively a cnReach module, but without a radio. So what this is useful for is adding serial and I/O connectivity to a broadband radio. So if you deploy one of the, for example, a PMP450i subscriber module or a PTP670 endpoint on a point-to-point link, you can add the Ethernet serial and analog digital capability to that endpoint and make those different kinds of applications functional. You'll also see the new wire replacement feature that we're introducing supports this I/O expander as well. So there's a lot of different unique applications that can be built and deployed using the I/O expander. Recently, we introduced the real-time spectrum analyzer. So this gives you a visibility of what's happening in the spectrum. So, and allows you to either in a license mode understand if there's some interfere that's not supposed to be there, or in an unlicensed mode, you can do things like block out part of the channel if you see particularly high levels of noise in one part of the channel. So you can ask the radio not to hop into those areas that you're trying to avoid. So a spectrum analyzer really helps with doing that, both planning as well as troubleshooting. So that's kind of the brief, very, very quick overview of the product itself. What I'll spend the next few minutes on is some of the updates that we have coming. So this month we'll be releasing the 0121 software release. This is primarily a maintenance release. It adds some number of performance enhancements and defect corrections in the software itself. We've made some improvements to the GUI. We continue to improve the GUI to make it simpler and easier to use, and I guess more difficult to get yourself into trouble with configuration. So simplifying and streamlining the configuration of the radio. We've also added things like network time protocol and some other features. So that's a relatively minor release, but it will be going out with new shipments starting in August, and will be available on our support website as well with all the release notes and information about that to come. Then a bigger release in 0130 coming out in Q4. This will support cnMaestro management as well as the wire replacement feature, which I'll talk about in a little bit more detail. And that release will also be compatible and supported for the high availability master station. So this is something else that I'll talk about here in a moment. So as far as cnMaestro support, it's been a long time coming, but we are now moving into demonstrations and moving into beta here in early September, and expect to have it fully released in the end of September, early October. What we'll be able to do with cnMaestro, and this will also be very unique and differentiating compared to the other industrial radios in the market, is being able to do, if you're familiar with cnMaestro, you can onboard a radio just like you would onboard a subscriber module. Once you onboard it, you can manage that device, see the performance, see where it sits in the network. With this version of firmware coming out in fourth quarter, 0130, you'll be able to push configuration files to the radio. You'll be able to push firmware updates to the radios. So all in a managed fashion. And this is especially important with cnReach, where on a narrowband connection, the firmware updates, pushing a 8 to 10 meg file over a narrowband link can take 4 to 5 hours. So Maestro can manage all of that. You can push all of the firmware updates over the night, or start it off in the morning, and then later in the afternoon come back and actually activate and commit those firmware updates to the radios. So you don't have to sit there and watch it or monitor it. It actually takes over and does that firmware update for you. You can also pull configurations and push configurations to each of the radios. Maybe these are a little bit out of order here, but this is also showing the dashboard on cnMaestro. You'll be able to see the geographical location of the radio, if there's any alarms on the radio, and what kind of throughput and capacity it's currently carrying, along with history on what the performance has been over a longer period of time. We also automatically capture the hierarchy, and you'll be able to tell automatically if it's an access point or an endpoint, or any of the statistics or information about the radio. So this is a pretty major enhancement to the cnReach platform, and really looking forward to some demonstrations coming up here in the next week or so, and then moving towards beta customers in September. Another new feature that we are currently in beta test with a number of customers is what we call wire replacement. This is a capability, I kind of show it pictorially here, that I can take a analog or digital input on one radio and automatically have it replicate to the output on another radio. So as an example, in the top here, if I have a tank level sensor that's varying from 4 to 20 milliamps output current, that's coming into that directly into the cnReach analog input, you can tell that cnReach radio, I want to have port X on this other radio follow that analog input and make that analog output at the other end. And similarly with a dry contact switch or any kind of on-off digital input, I can replicate that output to the far end of the link. So what we find is that there's a number of different applications that have wires that go from point A to point B. They might be buried in the ground. They might be going through conduit. And over time, they may decay or be water or rodents get into that wire, and just the reliability and durability is breaking down. So this becomes a nice feature to replace some of that aging wire infrastructure. It also becomes a nice feature where I don't have the wire, but it was cost prohibitive to put that wire in. This becomes a nice alternative. So lots of interest in this feature because it really leverages the radio capability, but also the general purpose IO. And of course, this also works with the IO expander. So if you have a broadband network, you can send analog or digital signals over the air across the broadband network to another IO expander anywhere else, well, effectively anywhere else in the world, but anywhere else on the network, and drive basically a point-to-point physical parameter. The HA master station. So this is a high availability solution. In the picture on the lower left, you'll see a rack mount device. Inside that rack, there are 2 cnReach modules and 2 power supplies. The cnReach, the master station, if one of the radios fails, it will automatically swing over to the backup radios. Similarly, with power supplies, it'll swing over to the backup. And you can also, during, say, a maintenance window, you can have it move from one radio to another. And this device can be deployed anywhere as either an access point or an endpoint, or in a point-to-point environment as well. And it's available in all the bands. So this is, we have samples of this now. We're out doing some field testing, and we look to launch this here coming up in fourth quarter, pending final FCC approval. I'll also just point out that we offer a number of antenna and turnkey installation kits. So we offer both Yagis and Omnis in all the different bands. And then we also offer this turnkey installation kit. So you can purchase the antenna as part of the bill of materials, and then also get the installation kit, which adds all the surge suppressors, the wire ties, weatherproofing, the jumper cable to get you from the inside of the cabinet to the bulkhead mount on the cabinet. So a nice complete system for dropping the cnReach radios into anywhere into the operation. So with that, I will wrap up. If you have any questions, feel free to chime in on the chat window. I've covered most of these points about what makes cnReach unique, so I won't belabor the point there. You can see it on the screen. I'll remind you that the webinar is recorded today, so if you want to share it with any of your colleagues or go back and reference it, you'll get a link via email to where it's posted, and you can view it at your leisure. So I don't see any questions on the line, so I'm going to wrap this up unless you have one quick last question. Otherwise, I will wrap it up, and thank you for attending, and I will talk to you next time down the road. Thanks, everybody.